So I continue on this session, paramagnetism. So in certain materials, each atoms or molecules possess a net permanent magnetic moment due to the orbital and spin magnetic moments. So even in the absence of external magnetic field, so the magnetic moments are randomly oriented in the absence of external magnetic field. This makes the magnetizations of the material nearly zero. So that is a little magnetization is present within the material. So, but when the external magnetic field is applied, the magnetic dipoles tend to align themselves in the directions of the magnetic field, and the material becomes magnetized. So this effect known as the paramagnetism. So this industrial thermal agitations disturbs aligned for the magnetic movements with and increases in a temperature. So the increases in a thermal agitations tends to the randomized the dipole directions are thus leading decrease in the magnetization. And so the implies that the paramagnetic susceptibility decreases with the increases in the temperature. It is observed that the paramagnetic susceptibility varies inversely with the temperature. So this is psi equal to C by T. This is known as the Curie law of paramagnetism, and C is the constant called Curie magnetic. And properties, the magnetic susceptibility is a positive and greatly depends on the temperature. It is given by psi is equal to C divided by T minus theta. It's a Curie wise law. And the magnetic lines of forces pass through the material. And then diamagnetism. So materials which does not have a permanent magnetic dipole, the termed as the diamagnetic material. These materials repel the magnetic lines of forces when external magnetic field is applied. So in these materials are even number of electrons, and all the electrons which spin in two opposite directions are almost equal, and so they cancel out and the net magnetic moment is zero. So they do not have any permanent magnetic moment or dipoles in the absence of external magnetic field. So but when the magnetic field is applied, these electrons reoriented themselves that the aligned opposite to the field direction and oppose the applied magnetic field. So hence the magnetic induction is almost reduced. Diamagnetic understood by the H equal to 0 and H is equal to H naught. So when the magnetic field H is 0, the atoms possess zero magnetic moment. When a magnetic field is applied in the direction, so the atoms acquired an induced magnetic moment in the direction opposite of the field. The strength of the induced magnetic moment is proportional to the applied field, and hence the magnetizations of the material varies linearly. So with the strength of the magnetic field, the induced dipoles and magnetization vanishes as soon as the applied field is removed. And the properties, they repel and magnetic lines of forces. The susceptibility is a negative and independent of a temperature and applied magnetic field strength. So the value of permeability is less than 1, and no permanent dipole moments in the absence of magnetic field. So when temperature is less than a critical temperature, diamagnetism becomes a normal materials. For example, gold, germanium, silver, lead, copper, silica, and organic materials also. And these are the magnetic susceptibility of some paramagnetic and diamagnetic substance. The paramagnetic substance aluminium is a 2.3 into 10 power minus 5, and calcium 1.9 into 10 power minus 5, and chromium 2.7 into 10 power minus 4, and lithium 2.1 into 10 power minus 4, magnesium 1.2, niobium 2.6, and oxygen 2.1, platinum 2.9, and tungsten 6.8. And then diamagnetic substance, bismuth is 1.66, and copper is 9.8, and diamond 2.2, gold 3.6, lead 1.7, mercury 2.9, and nitrogen 5.0, silver 2.6, silicon 4.2. And then these are the units of magnetic properties, the magnetic flux and magnetic flux density and magnetic induction, magnetic field strength, magnetic moment. These are the important terms: magnetization, mass magnetization and specific magnetization, and magnetic dipole moment, magnetic polarization, susceptibility, mass susceptibility, permeability, relative permeability, energy density, and diamagnetism factor. So these are the basic units of magnetic properties. Thank you. See you in next session.